So welcome everyone to the inaugural or first session of ASA Early Career Chapters How-To series. And this first session is on how to write proposals, telescopes, supercomputing, and more. And this session is being recorded, as you must have heard. So I'm Anshi Gupta. I'm postdoc at Curtin University. I will be your host today, and Chris Risley will be my co-host. He can say hi. Do you want to say hi?
Good thing. Thanks, Anshu. Hi, everyone. I'm Chris Risley. I'm a research fellow at the University of Bologna in Italy. So joining you from far overseas.
At 4 a.m. his time. All right. So just to begin with, we begin with acknowledgement of country. So in the spirit of reconciliation, the ASA ECR chapter acknowledges the traditional custodian of country throughout Australia and their connection to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today. And this meeting is follows ASA Code of Conduct. The ASA is committed to making ASA organized, sponsored, or supported meetings, events, publications, inclusive, productive, and enjoyable for everyone, regardless of age, caring responsibility, cultural diversity, disability, gender, indigeneity, sexual orientation, gender identity, physical appearance, or religion. So please follow these rules. All right, so let's begin our session. The session begins with two talks, one by Sarah Martell on how to write optical proposals, and then by Gregory Poole on HPC or ADEX proposal. So Sarah, would you like to share your presentation?
Sure, thank you. Oh,
and there is, if you have any questions throughout the presentation, please feel free to raise your hand or write in the chat box. If you have any anonymous question, please feel free to send them to Chris and he can ask them. Thanks.
Very good. All right. Well, so first of all, thank you very much for the invitation to do this. I think a how-to series is a great idea for the ECR chapter to do, so I'm really pleased to be able to contribute to that. I specifically have been asked to talk about observing proposals because I have written and read a lot of observing proposals. I am currently on 3 tacks, and I've been on a few others in the past. And so I spend a fair amount of time thinking about whether proposals that I'm reading are making the right case and whether they're convincing me of what I need to see as an assessor. I suspect that Greg and I will have some fairly similar themes in what we talk about, but I'm specifically going to be talking about observing proposals. And I just want to acknowledge that I got this background photo from Angel Sanchez, who does marvelous astrophotography along with wonderful H1 work in dwarf galaxies. So onward. So we write observing proposals because telescope time is a limited resource. And by this, I mean that major observatories often have oversubscriptions of a factor between 3 and over 10, right? So what that means is that the community has a lot of really good ideas and we don't have enough time to do all of them. And so we have to triage at some level. We have to prioritize and figure out what is the best match between what people want to do and the time we have available and the priorities of the observatory. So every observatory then will convene its own group of experts that have the appropriate knowledge and background to read the proposals that have been written and to decide, to recommend which ones of these should we actually execute. And depending on the observatory, this happens 1 or 2 or 4 times a year. The schedule is then laid out for the next however many months. And then while that's happening, we're thinking about the next selection. So it's a very forward-focused process all the time. And depending on where you're trying to get telescope time, their priorities can be a little bit different. So in some places, it's really important that everyone is included, that the whole community has access to at least some amount of observing time. In some places, you really want just the most headline-worthy science cases. It really depends on the particular observatory. And so this is a thing that you will want to know before you start writing proposals is, what is the attitude, basically? What are the priorities of the place that I'm looking for? In particular, things like space telescopes, really look for projects that can only be done with space telescopes. Because if you can do it from the ground, it is so much easier and cheaper to do it from the ground. They don't want to spend their time on that. They wanted to put their time into projects that can only be done from space. So, you know, number one, think about what you're asking for. And yeah, to continue with that thought, there are lots of different kinds of observing programs. There's short-term and long-term and large, and the ones where you need to coordinate the timing so that you're looking at the same target with two different things at the same time. And, you know, do you want them to take the observations for you? And there's a ton of detail in that, right? And not every observatory does all of these things. And so what they do all do is right at the beginning of every observing period, I'm going to go with semesters because that's pretty common, they'll write a call for proposals that says, here's what's available. Right, we have this many nights in dark time and gray time and bright time, which has to do with the phase of the moon and the sky brightness. You know, we have this many reserved for large programs, and just to kind of give you a sense of what's available. And so you should figure out which one of those will let you get the science done that you want to do, that will answer the question that you have. You know, do you just need one little bit of information, or do you need monitoring every 3 months for 2 years? You know, what's really going to get you the right answer, or the good enough information to work out what the right answer is. And then your job as a proposer is to tell the assessor what they need to know in order to put your proposal in that priority order, right? So what are you trying to learn? What is your science question? And so usually, these can come from anywhere. But a lot of times a science question for a new project comes from reading an existing paper and going, you know, there aren't a lot of points on the right side of the figure. I wonder if I could find some. I wonder if you added some, would you be able to learn something new, right? What would happen if this? What would happen if that? And so that's the thing that is driving your whole project. And so you need to be able to say pretty clearly, sort of elevator pitch wise, well, what are you trying to learn here? What's your question? But you also want to be able to say specifically, how is this project going to help? Right? So it's not just that we're going to learn some more things, we're going to look at some more galaxies, but like, how does that make it better? And be specific here. You also need to explain whether the targets you picked are the right ones, whether you've got enough of them or too many of them, and whether the data that you say you want to get is actually going to let you do the thing you want to do. So this is all of the case you need to lay out. And then finally, why do you need to do this now? Like, is there an aspect of urgency or timeliness or something to it? Did we just learn last year because of a Gaia data release that something exists and now you need to go follow that up and figure out how it fits into the larger picture? Was there just a fast radio burst and you want to know about its host galaxy, right? So like, is there, because if there is an aspect of like, we need to do this right now, or here's a big opportunity, or we should do this before JWST starts taking data, because then, you know, they'll take over. Those things are important to know in thinking about prioritizing the proposals. And so every observatory does everything on their own, and they all reinvent the wheel, and they all have a template of some kind for their proposals. And some of them give you software that you have to download and use, and some of them have a web page, and some of them say, send us a PDF. But they will tell you what they want, right? The call for proposals tells you what they want. And so sometimes they're very open-ended, and they say, write us 2 pages of scientific justification, 2 pages of technical justification, go. And that's difficult when you're getting started at this, because you don't know what needs to go in there, and you might worry that you're leaving out details. And so it can be very helpful to ask people who've done this before, you know, what information do they need to know? So you write up what you think you need to say, and then you hand it to someone and say, what am I leaving out here? Right? And they can say, oh, well, you know, it might explain, you know, can you do this in bright time, or do you need dark time to do it? And, you know, whatever it is, just so that you get all your details in there. And some observatories, and I'm thinking about ESO here, very specific about what they want to know. And they'll ask you, not just what data are you going to take or what is your science objective, but what exactly are you going to measure? Like, what's the thing you're going to do with these images? Are you going to make difference images? Are you going to, whatever it is, are you going to look at surface brightness? Tell us exactly what you're doing here. Are there already data in the archive you could use for this? Did you check? Did you run the exposure time calculator? Do you know that you're going to get the data quality that you say you need? All that kind of thing. And so, I mean, those proposals can even be a good template for the more open-ended observatories as well, just to make sure you've got everything in there and got all your bases covered. So that's the information you need to put in, but how do you make it effective, right? What is it that is going to make the people reading it go, wow, this one, we're going to do this one, right? So the first thing that I would say is to be specific, right? So be specific about what you're going to do with the data. Be specific about what you're going to learn from the project. So the more that you can say, here's what I'm going to do, right? I'm going to quantify this. I'm going to find the ratio of, this kind of galaxy to that kind of galaxy as a function of redshift. I'm going to demonstrate this thing. I'm going to disprove this model. I'm going to distinguish between, these two possible values for the Hubble constant. Whatever it is, try to be really specific about what you're trying to do, because a lot of people say that they want to characterize the mass distribution of exoplanets. But what does that mean? What does that actually mean, right? You can, and they know if you were to press them in person, they would be able to tell you, well, I want to know what the slope of the mass function is, because that connects to planet formation models. Say that. That's way more convincing. It tells me as a reader that you have a plan for the data and that you're going to do a specific thing with it. Try not to constrain things. Constraining happens a lot, but it is more helpful to the reader if you can say, because I want to put a lower limit on the supernova rate in galaxies of this mass. I want to, not just constrain a thing, but I want to, specifically, I want to know, is it above this level that's predicted by the model that I care about? Something like that. Because I think we all can fall into a place of just going, this is my favorite target. I love globular clusters and they're the best thing in the world. And I just want to know everything about, this is 47 Tech, and it's so great, and I just want to learn everything about it. Not scientifically convincing, I'm sorry to say. I need to know a little bit more about what you're going to do. We all love our favorite targets, right? Give me more. Another way to think about this is to say, you're going to write a paper out of this. That's the idea. Observatories get really sad when you take data and then don't write papers. That is not what they're there for. They really want you to do the science and progress the field and all of that. So probably you can think of, what's your key figure going to be? What's the thing you want to measure? What's the number that'll tell you if, fully convective stars, happen at this mass and below or that mass and below? Like, what's the thing? What's the specific thing? And how can you put that into the proposal? You want to demonstrate what you're going to do as much as possible. I find this really helpful when I'm reading proposals. When people say, well, I'm going to, we're going to measure the magnetic field on the surface of this star, and then that's going to tell us about our dynamo models for low mass stars. I'm like, that's cool, but can you show me the model and show me how the measurement would fit onto what it looks like? So I would prefer to read a sentence that says, doubling the sample size will reduce the Poisson uncertainty on the measurement by 20%. And that would make it possible to tell whether model X or model Y is correct. This is what I want, right? Show me how the new data make it better. And particularly if you can put it in plot form, if you can say figure 1 shows model spectra for a star like those in our sample, with effective temperature of 4,500, log G of 3, and metallicity ranging from -2 to +1. The data we're requesting will be able to determine metallicity within 0.15 dex for all 300 of our target stars. This will allow us to measure radial and vertical metallicity gradients across our zone of interest, which have been shown by X et al. To correlate with the efficiency of supernova feedback, right? So like, here's a plot of it. Here's what changes as metallicity changes. Here's what changes in the data we'll take. And if the signal to noise is what we want, we can tell the difference between case A and case B. Right. So I have a science question that is relevant and compelling and timely. And the data I'm going to take will actually let me answer the question. Here is a calculation, here's a model, here's synthetic data, here is some demonstration so that you know, so that you have some confidence that it's actually going to work out. And then to go beyond that, so this is a really nice example of that kind of demonstration, right? This is a figure from Perlmutter and Schmidt in 2003. This is the supernova Hubble diagram. And you know, so you could state it as, if we observe targets as high redshift where the models diverge, and we have particular precision in the magnitudes in the distance modulus and the redshift, then we can state confidently whether the expansion of the universe is accelerating, right? So if they'd said we want to characterize what the supernova redshift distribution is, or we want to determine which model, like it's just, you could be really vague about this, but you can also be really specific. And you can say, look, if we do a measurement in this range of parameter space, we have this accuracy, here's what we can do with it. We can tell the difference between, you know, omega lambda is 0 and omega lambda is 0.7. And then you want to go past that and you want to tell me why that matters, right? So then you want to go on and say, this would have many important implications for cosmology, including X and Y, which connect to the central question of this project. And it would allow us to make new predictions about Z. And most things we propose wouldn't get you the Nobel Prize, but this one, right? Which is why it's such a nice, clear case. You can really tell the difference. And this is exactly the kind of demonstration and then follow up with the outcome that is really effective in a telescope proposal. Here's what I'm going to do. Here's why it matters. Let's go. And so there's a lot of detail that goes into this. Every observatory has at least one telescope and at least one instrument, and every instrument has at least one setting and readout mode and all of that stuff, one filter or grading or something. And so you need to explain everything. Why is this the right way to do it? Again, a lot of this can be really unfamiliar. If it's a new instrument, I will, if I'm trying to propose for a new instrument, I will call up my colleague who uses that and say, hey, here's what I want to do. And here's what I'm thinking from looking at the manual, but you know this better than I do. Is that right? You know, and then they are, you know, using their knowledge. And it's always really nice to have people ask you about the thing that you have spent so much time getting good at. And you're explaining why you want a certain kind of data or certain characteristics or whatever, that helps you figure out what it is exactly to do with the resolution or the filters or whatever it is you need to choose. There are a lot of details that when you get used to working in a particular domain, do not carry over to other domains. And so what I mean is, if I were going to write a photometry proposal, I would be in trouble because I don't do that. I do spectroscopy. I don't know what's normal. I don't know what the right way to set it up is. I don't know the calibrations. I don't know a lot about dithering. Like, there's a whole thing, right? And in order to make a convincing case that I can use this data and do something good with it, I would need to convey in the proposal that I've figured that out. And if I just say, well, you know, I'll take some images and work it out, that's not convincing. But if I've gotten together with my colleagues and said, okay, you know, here's the thing, here's the outcome we want, how do we get there? Then we can explain that, you know, our calibrations are right, and the you know, the index we're going to measure, the spectral index of whatever makes sense, all that kind of thing. Also, a lot of observatories, it's becoming more common for proposals to be anonymized, in which names are taken off of them before we see them as assessors. And also proposers are asked to do their references to previous work just as numbers rather than as names. So like physics style rather than astronomy style. And this is so that when assessors are reading it, they're not thinking, oh, I know this person, or, oh, that's a weird name. I don't know if this person knows what they're doing, or whatever it is, but just thinking, is this science we want to do? And this has been demonstrated with big places like Space Telescope, that this actually does have an impact on who gets time, and that it's more fairly distributed when we do things anonymously. So at the AAT, we have been doing anonymous review for a couple of years now. It's a small enough ecosystem that we don't see any significant differences, because small samples, it's hard to know if you're making a difference or not. But definitely check that. And that'll be in the call for proposals for sure. Check that you're doing whatever it is you need to do there with your details, so that your proposal fits the style requirements as well as the content requirements. And then don't just write something and send it off. Edit, give it to your friends and say, would you give me time for this? Because the people who are reading this aren't you, they don't know what you know. Believe it or not, you are the expert on your thing. And other people might be experts on other things, but that does not mean that they understand what you're after. And so you want to bounce anything you write off of people who don't know what you know, and make sure that you're explaining it, that you're conveying what is the interesting question, why is this compelling. We all have people, I think that I'm a big proponent of working together on a lot of things. And I think that we all have people that are going to be able to give us useful feedback, and we should use that. I also find it very useful if, in writing proposals, if there's a way I can say, look, I'm trying to measure this. And if it turns out I can't measure that thing from the data, that still means something, right? So if you can have a backup plan that's like even if the abundances don't have this pattern that we're looking for, that means something else happened, right? So then we can make some further inferences, and you might give a little paragraph about like what else it might mean if the feature you're looking for doesn't exist. And then in terms of writing style, I've kind of two things. And one of them is, if it feels like there's some overused phrasing in your field, don't use it, right? Because everyone reading what you're writing has also read it a million times, and they know the dwarf galaxies are the building blocks of galaxy halos, but like, give me something new. Assume that that's, take it as read and tell me what you're really after. And then also, and this is maybe the most effective thing, honestly, is to read as many other proposals as possible and see what rhetorical structure, what information, what way of conveying information is effective, right? What do you read and you go, oh, I don't even know about exoplanets. And I think that that's amazing, right? That's, and just reading a whole, and everybody has style, it's different, and everybody has different ways of structuring these things. And so getting as much exposure as you can to the way that people make this case for, this is my program and we should do it, is really helpful. And I again, call your friends, call your colleagues, and just see what they're willing to share with you, because that can be extremely useful. So that's my summary. Do those things. And finally, everything is always oversubscribed. The answer to a proposal might be no. And in that case, see if you can tighten it up, try it again. You cannot get telescope time if you don't apply for it. So, get out there.
Thanks, Sarah. That was a really good motivation. Let's give her a round of applause. If you fail once, then try it again.
Exactly.
Yeah.
I've been not approved for so many observing proposals.
Absolutely. So, absolutely, yeah. So if we'll take questions towards the end of the second talk, to all of them together. after Greg's talk. So Greg, can you go ahead and share your screen and we can learn about HPC proposals now and ADEX proposals.
Thanks, Anshu, and thanks, Sarah, for a great introduction. I don't know if I need to give my talk now. Sarah's really covered the material so well at this point. At the start, I was starting to go, oh no, we should have compared slides because I'm just saying the same things. But I've realized now, pulling back, that I actually am taking a slightly different approach with my chat. I'm essentially going to be echoing a lot of what Sarah's already said, but I'll be doing it from a slightly different perspective. And I'll spend a little bit of time at the beginning just talking about the ADEX program because some of you might know about it. And there are some important differences between it and telescope proposals. But it's natural that the program will be very similar because with everything ADEX does, we try to work within the cultural norms of the astronomy community. So the allocation program that we've come up with is patterned off of the AAT's program, which is similar to other telescope programs. So it should all look and feel familiar, but there'll be some important differences. So can everybody see my slides? All right. Okay, good. So just a quick word about me for those of you who haven't come across me before. We're not getting to mingle in public spaces quite the way we were. So I'm sure there's a lot of people in the community that I haven't had a chance to meet yet. I was a cosmological simulator up until about 2016, at which time I transitioned, if you will, to a software engineering role within ADAX. And I'll explain in a minute what ADAX is to those that haven't come across it before. In 2017, I then took on the role as program manager of the group at Swinburne. And as part of that role, I have acted as the secretary for the allocation committee for ADAX proposals. And in that role, I've observed, I haven't been involved in the assessment. My role is to facilitate that meeting and make sure that everything runs smoothly. But I've observed the assessment of 114 proposals in that role now. And there's two big patterns that I've observed in that capacity that I want to touch on today. So what is ADAX? ADAX was started in 2017 on the back of funding from Astronomy Australia Limited, ultimately money that comes through an NCRIS allocation. We provide astronomy-focused training, support, and expertise. And the idea originally here and still is to maximize the investments that Australian astronomers are making in computing infrastructure. There's three components to the services we provide. One is training. One is software support for the AusStar supercomputer. So if you need packages installed on AusStar, those tickets often come to ADAX staff to do that work. And national support. So in that role, we manage a data portal called the GET-MCP, which so it's a service whereby if you say publish an article on PASA and you have some data that you want to attach to the article, we can house it in our data store. It gets a DOI, and it's got support around to ensure the longevity of the access to that data. And two allocation programs, one for the Astronomy Supercomputing Time Allocation Committee, ASTAC, and then the other is the ADAX Merit Allocation Program, which is a program whereby you can compete for time, our software engineers' time, either to build software solutions or to deliver bespoke training. There's two nodes for ADAX. One is based at Swinburne and one's at Curtin. The Curtin node tends to do more of the training work, but they also do software work. And the Swinburne node tends to do more of the software, but we do some training as well. So that's ADAX. The ADAX Merit Allocation Program is, like I said, put together the idea here was to try to work within the cultural norms of our community. So it should look and feel a lot like a telescope proposal or a supercomputing proposal. The difference here is, though, is it's not realistic to expect researchers to know how much of our software engineers' time it will take to deliver a solution or to execute a certain task. For an observing proposal, the onus is on you guys to make the argument for how many targets you need to observe and how long you need to observe them to reach certain depths, to reach certain science goals, all that sort of stuff. So ultimately, it's up to you to argue how much time you need. And it's up to the allocation committee to decide whether you've effectively done that or not. That is not the way it's done for an ADAX proposal. Instead, we ask people to submit an expression of interest to the program, and then we will work with people who submit EOIs, and we'll work together. And ultimately, it's us that comes up with the number of how much work is required. And we'll iterate with you to come down to a project that's of a suitable scale and scope. But otherwise, it is a lot like a telescope proposal. There's a couple pages for the scientific justification, a page for the technical justification, some short answer questions, that kind of thing. And then it goes on to an independent committee that assesses time based on and kind of tries to figure out which projects to support. If you have any questions about any of that, there's a link here about how to apply to the program. So here's a list of projects that were accepted up until 2021A. It doesn't include the current semester. The point I just want to make here is just the variety of the projects that are involved. We can do web applications, CPU optimization, GPU optimization. Like I said earlier, we can provide bespoke training now as well. We've done mobile apps, database optimization, just about anything you can think of, we can help you with. We've hired for breadth of experience and knowledge. And we've also have in-house, half of us come from astronomy background, so we can talk with you in the language that you're used to. But we have a very diverse set of computing skills and backgrounds. So we can, if we can't do it for you, we can probably figure out how to. So that's the background. So now merit allocation programs and all the points of Sarah's that I'm now going to reinforce. So like Sarah said, why do we have merit allocation programs? Well, it's because our community has some scarce resources and we want to manage those scarce resources prudently. So I don't know about you, but often when I've gone through an allocation process of any sort, I feel a little bit like one of these poor dogs standing in a line hoping to get my fill. And it is that is essentially the problem, isn't it? We've got to decide who's going to get what of this resource. And the task that we have set for ourselves today is to try and understand how we can most effectively get the attention of those that are the gatekeepers to these resources that we're looking for. I think the way I sort of frame my response to that task is to say that, well, what we need to do is try to empathize with the allocation committees that are doing this work. So despite the credit in the bottom there, this is a picture I took from the last allocation committee I was in. Everybody sits in suits and they've got tablets here with pie charts and bar charts, and it's all done very, very formally like this, lots of stony faces. So let's try to get into the minds of these people that are doing this work. And the first thing to note for those that haven't been through this sort of process before is what the task is. Effectively, the task is to transform that stack of papers that's on the left there to something that looks like the stack of papers on the right. And there's lots of ways you can do that. And there's, you can be as formal as you want about the whole thing, but the reality is that, and most of us here will have at least done some marking of assignments through the years, you know, you get 2/3 of the way through the stack, and what starts to happen, you know, that student just really didn't listen to the instructions that were given in the question, and you start getting annoyed. And what is a competitive process just starts to get a little bit, and what is an uphill battle to win the favor of the reader just gets steeper if you start making some simple mistakes. So one thing that I want to emphasize when you're dealing with proposals and application processes is just to have good table manners. It really shouldn't need to be said, but it is, you know, it is quite frequent that these sort of things actually do on some level really matter, especially when you're coming down to, there's a line that needs to be drawn here, and there's some people on this side and some people on this side. So reading and following the instructions is important. And it may very well be this is your 3rd time applying to a program. Watch out, they might have changed the rules on you since the last time you read them. And it is always worth double checking you are agreeing to abide by the rules of the program. And it is your responsibility to make sure you know what those rules are. So just get that one out of the way first. Make sure it's easy to read. Remember, they're reading that stack of papers on the left. Don't make it hard for them. Make what you're saying, make your message clear, make it concise. I say here, don't be too technical. Now, that doesn't mean don't be technical, but do acknowledge the fact, just like Sarah said, that these people aren't necessarily experts in your domain. They might be astronomers, but they might not be a stellar observer like you, or they might not be a galaxy simulator. You need to make sure that the message is clear to the whole of the committee, which may have people from quite a diverse range of backgrounds. In the case of the ADAX program, we have some people that aren't formally astronomers, they do astronomy work, but come from software engineering backgrounds. So in particular with the ADAX proposals, don't get too scientifically technical. Don't try to play tricks with the margins, the font sizes, etc. If you're doing that, you're probably violating point 2 here. They've given you enough space. They've given you the space they want you to fill. If you're trying to cram more words in there, you're just making reading that stack of papers on the left more difficult. And no matter how valid the points you're making, they will start zoning out and having troubles hearing what it is you're trying to say if you're making it too difficult. So be concise, you know, be efficient with your use of words, and obviously check spelling, grammar, and all that sort of stuff. Last point. In this task of empathizing with the committee, what is it they really want to do? They really want to be confident that the resources that they're allocating are being utilized in the best possible way. And the way this usually comes up in the context of the ADAX committee is impact. They want to know what the impact of this work is in the clearest sense of the word. So what is impact? Impact is compelling, it's important to the community, and it speaks of consequences. So in terms of compelling, ideally, to be evidence-based and quantitative in explaining why this is important. So if there are relevant metrics involved, measure them. So in the case of ADAX proposals, profile the code. If you're saying that it's too slow, profile the code, figure out where it's slow, figure out how much could be gained from speeding up that bit of the code or reducing the runtime to 0 in the limiting case, and be quantitative. So some simple profiling of code bases that you want to optimize will have a huge impact on the demonstrated impact of your proposal. Run scaling tests. If you're writing an ASTAC proposal to run something that you run on your laptop, or you want to now run it on a supercomputer, and you want to multiplex, run some scaling tests and make sure that the code will continue to scale up to the resources that you're asking it. And if it won't, quantify the effect So the TAC knows, because they'll be savvy and they'll be aware that this is an issue, quantify the effect of the kind of scaling losses that you might expect by going up to a supercomputer. Make sure it's important to the community. One great way is the Decadal Plan. So one of the big reasons why the community spends so much time and effort writing the Decadal Plan and reviewing it halfway through every 5 years after is because it is a great resource where the whole community can point and say, look, we've all agreed that this is important. And just point to it and say, look, point 5 in the Decadal Plan says that this is important. Discuss the impact of related literature. So if there's been several Nature articles kind of close to the topic that you're addressing, that speaks to the impact of the work that you're proposing. And a clearly articulated impact also speaks of consequences. So, for example, if we're running simulations of a higher resolution, it will allow us to probe new physics. So not I want to run a simulation with 10 times more particles, but doing that is going to get me here. I want to increase the size of the community using a software package by a certain %. Okay, so it's not just that you want the code to be refactored so that it's easier for people to develop on. The consequences of that are larger uptake of the code base. What it's not is unsubstantiated. Wow, wouldn't this be cool to do? I mean, of course it would be cool to do. It's astronomy. Everything we do is cool. So we don't, and trust me, this is important work. Right? And I'm basically just flipping the points I made on the previous slide here. Quantify these things. Point to the Decadal Plan and things like that. Lacking demonstrative importance to the community. So these are community resources that TAC generally wants to see community benefit from their use. Not necessarily, but it's something to consider. Certainly in the context of ADAC's proposals, their community benefit is weighed quite highly. Impact is not inconsequential or progress for its own sake. I want to increase my sample galaxies by a factor of 5. Who cares? This will make my code run twice as fast. So what? So does that mean you're going to be able to get a coffee more often? Who cares? I'll be able to run a simulation with 10 times more particles. The impact is the new physics of that, the new regimes of the physics that you'll be able to probe because of that. So I want to just end with one anecdote that I use sometimes in my talks. I don't know. Some people might have seen me talk about this before. So there's a talk that Linus Torvalds gives about Git at Google in 2007. I don't know if anybody's actually watched this talk, but it's extremely entertaining in some ways that are a bit wrong. He is very caustic. I think a direct quote at one point in the talk is, if you don't use Git, you are ugly and stupid. But it's all really quite entertaining. I think he knows what he's doing when he says these things. But there's a point, and this gives a link to the actual time where he's doing this in the talk, towards the end of the talk, where he's talking about how version control systems before Git really spend a lot of time on branching and trying to optimize branching. And he's like, it doesn't matter. The only thing that really matters is how quickly you can merge a new branch of code. And he goes on to talk a little bit about that. And he makes it the point that by making merging quicker, he has been able to totally revolutionize his workflow. So, and it's not so much, it's not so much that the merging is happening faster. It's that and this is the quote from the talk, that's the kind of performance that actually changes how you work. So the importance of performance isn't that you're doing the same thing faster or bigger. The importance is the new capabilities that result. So I just leave that with you as a little anecdote. sort of illustrating the point that I'm trying to make. I talked about having good table manners, but mostly I just want to emphasize with you all when you're writing proposals, emphasize impact, make it compelling, make it important, and make it consequential. And that's all I wanted to say today.
Thanks, Greg. Let's give a round of applause to Greg. And you're right, the 3 impact, and the 3 make it consequential, all of those are valid across all proposals, I guess, telescope or HPC or anything. Yeah, it's a good statement. All right, so it's time for questions, and I'll hand it over to Chris to moderate that part. Chris?
Absolutely. Thank you, Anshu. And thank you, Sarah and Greg, for those fantastic talks. Extremely accessible for someone who is, a scientist and makes a lot of use of HPC resources, but has only really kind of dabbled in proposing for HPC time. Just extremely accessible and hugely important points. Do we have any questions from the audience here? I have a couple of my own that I can kick things off with, but if anyone has any particularly burning ones, then feel free to raise your hand or just unmute yourselves and jump in. Okay, we have a great question from Nicole. What happens if you don't know whether the science you propose for will happen? And she gives the particular example of the epoch of reionization. So I guess this is a question directed mainly to Sarah.
Indeed. Well, I think that you should take the spirit of everyone who's been saying the James Webb Space Telescope will be launched in 2010, since 2010.
Or that LIGO will one day observe gravitational waves.
Exactly. I think, I mean, what you're trying to do in the specific case of epoch of reionization work is to see what your capabilities are. And so I think that there's a really nice way to lay out, like, here's, if I can do this well, here's what I could see. And, if this is there, and you can come up with like case ABC, if reionization was at this redshift and things behave this way, then here's what we would observe, and here are the things that would look different to me. It's all, it's all mysterious, but I think you can still make a case for, with some models or with some sort of toy model kind of predictions. You can at least give me a visual of, like, here's what I could measure, here's what I'm comparing it against.
I think the EOR community is a great example of how this is done. The EOR community continues to get resources, and one of the ways they've been doing that is there are models. The constraints from the observations are slowly marching down. And my understanding is we are at the point now where models are starting to get ruled out. And it's been a slow incremental process. And I think the EOR community's been quite good at managing this problem.
Yeah, it's kind of like particle physics.
Yeah.
The same kind of chipping away at the observability.
And the gravitational wave community as well. They chipped away, always sort of reaching for what that next rung was. There was models that, perhaps extreme, that they were able to eliminate at the start. And the model, until they finally get down to reality, which is where they are today.
Great. Thanks, Sarah and Greg and Nicole. We've also had a question from Themia. To Sarah, is there any special consideration you would recommend for distributed peer review process?
Ooh. In terms of how do you write to a peer review process versus a panel? Oh, that's a good question. I don't know. I don't necessarily think so off the top of my head. I mean, we're still looking for the same things. But you're right that in a peer review process, the starting point's a little bit different. I hadn't really thought about that much. Nothing jumped out at me immediately.
I can actually possibly touch on that a little bit. Having been involved in distributed peer review process for telescope time, one of the main telescopes in my experience that uses that is the GMRT in India. So I think one of the things that you might be able to not necessarily rely on, but perhaps bet on perhaps, is that your proposal will be sent to someone who is more likely to be an expert in your field. So you might be able to go slightly deeper into the nitty-gritty details than you would on a standard TAC review process. I wouldn't necessarily rely on that, but you've got a pretty good chance of that. Okay, do we have any further questions? I have some sort of slightly more technical questions for Greg regarding some of the ADAX proposals, principally because one of the main pieces of software that I like to use for my data processing is this rather behemoth piece of software called ddFacet that is very much written by astronomers and not so much by computer scientists. And there are some areas in which I think it could be improved with the assistance of some actual professional code writers. So what are the key steps that I would need to go through to talk with someone at ADAX about scoping out requirements and particularly identifying chunks where performance improvements could be made?
Well, we'll be making an announcement in the next week or two saying that it used to be that we started the UI process just a few weeks out from the proposal process. Now we're trying to accept the UIs more continuously over the semester so that we have longer to work with the science teams. So there'll be an announcement in the coming weeks. Just respond to it. The UIs absolutely should not be any kind of barrier to entry. Make the language informal, just clearly state the problem. It's really just about kicking off a conversation. So respond to that email when I send it out and we'll have a talk about it. Don't feel shy about the fact that the code is written by astronomers. That is the entire reason why ADAX exists, is because of how much software is written by astronomers. Where our stated goal is to raise the standard of software, of the construction of software within our community, but also we acknowledge the fact that it's a very difficult task and we really shouldn't be expecting astronomers to write professional code. So don't be shy about it. And we have worked on several projects. Several projects have gotten through the TAC that were effectively just sort of refactoring and professionalizing important code bases. But I'll just point back to my slide deck. It's all about the impact. What is the impact of doing that? Does it mean that the code's going to run more reliably on supercomputing facilities, in which case try to quantify that effect? Does it mean that the audience will be a lot larger, that you've got stated interest from international collaborators that would like to use the code base if only it was easier to work with? Quantify it, but it's just really at the end of the day about impact.
Thanks, Greg. Yeah, definitely important points, and I will be following up on that ad because this is something that's been on my to-do list for a while. Okay, we have a raised hand. If you feel free to go ahead and unmute yourself and ask a question.
Hi, Chris. Thank you. So a question for Gregory, actually. So I have a code that I have optimized to train across nodes of GPUs. It took me approximately 5 months to do this as an astronomer, which is a long time to spend on a code. I was wondering, like, if we propose a project and we get it accepted, how involved are we in the process of getting our codes optimized? Because while it was very long and very painful, I learned so much. So now I'm like a pro with GPUs, so I'm happy. So I was wondering if we have some involvement.
I hope you'll consider applying for jobs when we post them down the line. It varies. There's some science. So we're the development team and you would be the science team is the language we use. It really varies the engagement of the science team. There's some projects where the science team is very involved and we work quite collaboratively with them. Other projects where, unlike what you're describing, they have some sense that maybe this code can be GPU optimized and they just want us to do it. So it really depends on the situation. It would be an asset to the project if you were able to be involved. It would be an asset to the project if you had expertise. But the trick you would have then would be in selling the project and explaining why you need us involved. Is it just because you don't have the time to do it? In which case, well, the tack would be like, they want us, maybe a slide I should have had in my slide deck was that the TAC is really interested in applications for our capability, not so much our capacity. So proposals that just sound like they need some more, if they would have a postdoc do it, if only they had another postdoc, those don't tend to play very well with the TAC because it is such a scarce resource. Proposals that make it clear that you need our expertise, that it's a struggle for you to figure out how to do it. So you would just have to make sure that that was clear, and that would be the tightrope you'd be walking there.
Yeah.
The balance between, look, it's an asset that I've got experience here, and I could be involved in the project and add muscle. And then the other side being, well, then why is ADAX involved? Okay, because I really need that next level of expertise. But it sounds like a great project for us to be involved in. I encourage you to apply.
Okay, thank you so much. I appreciate it. Thank you.
Okay, at that point, seeing as it is now on the hour, I think it's probably best if we wrap up the questions here and say thanks to Sarah and Greg, and then we can begin to head on into the breakout rooms.